Yeah, so I think Aditya, you had a few questions that you wanted to ask. I think you can ask them right now. Uh,
Yeah, first, can you tell us a bit more about ROS? Like
yeah,
how
yeah.
does it
So
stand?
this is something that you wanted to know. Uh, yeah, is there? I'll sort of get to that. Uh, but is there anything else? Because I might spend a couple minutes on that. Is there anything else that you wanted to know, like something quick? Uh,
My doubts are kind of related to ROS. So yeah.
oh, okay, okay, okay. I'll get to that. But yeah, does anyone else have something like very simple question before, because I might spend like a couple minutes on this. So Alan, or I think if Avni is still there, yeah. Uh, okay, if you want, you can just ping. So if you want to get, where are you particularly stuck at? Are you trying to start off with ROS, or what? What is the status?
Not exactly starting with ROS. I mean, I had this problem when I was trying this bin picking thing in Gazebo. So, like, how much you need to grasp and all that, I wasn't able to extract the exact function and all in ROS. I mean, because there are all these inbuilt functions, but how do I get exact function for this kind of behavior?
Oh, okay. So that's a very specific question. So uh, you said you wanted to grasp something. Are you using like a robotic arm?
Yeah, yeah. I'm using like a four arm sort of a gripper, which I designed myself actually.
Oh, okay.
Yeah.
Oh, okay, okay. So have you attached some sort of force sensors to them? Tensile sensor, like.
Yeah. How do I import all these things in ROS and sort of get started with
Oh,
this?
okay, okay, okay. So you're using Gazebo, right?
Yes, I'm using a zero.
Okay. So Gazebo and ROS, that combination is kind of messy to work with. So I think what you need to do is you need to write plugins. So these are like custom made functions. So for things that do not exist, you can probably see. So things for things that do not exist right off the bat, uh, you sort of have to write down certain skeletal code yourself. Uh, yeah, this is sort of gets messy. Uh, let's see if there's something available. I have actually not done this. Like I've sort of played around with plugins, but I've not done this specific hand gripper thing. Uh, let's see.
I also looked at like a pre-made example on a KUKA robot, which
Yeah.
is used for the same application, but I couldn't exactly get the things they were in the code.
Huh. Okay. Okay. I see. Yeah. We can actually discuss this offline. So I can sort of let me see what I can collect, and can you can also send me the
Yeah,
specifics of your
maybe I'll.
problem.
Yeah,
Yeah. Yeah.
yep. I'll send you all the details.
Yeah. Because so yeah, let me send you a few other links because there is something that you need to do with ROS itself. So I think you need to write your own certain scripts in ROS itself. Let's see. Oops. So are you aware of all the publishing and subscribing stuff that's used in ROS?
Yep, yep. I've
Okay, okay.
done the basics. Yeah.
Okay, so you've all done the basics, right? So you can probably look at certain things here, like intermediate level. Uh, I'm not sure if you might have to write custom messages, but yeah, we can have a look. at, after the end. Yeah.
Yeah, I'll message you with all the details.
Yeah. 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 Okay. Is there any other questions?
Also, Sharat, could you tell us like more projects, like some other interesting projects we could do with all that we have learned, apart from the OpenAI thing?
Okay. Yeah.
Like something we can implement by ourselves and which can have something, like we can have something tangible.
Okay. Yeah. So you can probably think of implementing like something like A star, like a navigation problem entirely in VRUP. You can think of coding everything from scratch. Uh, might be a little complicated, but it could be doable in like a week's time. Um, in fact, I also did send a link to that in last week's lesson. So that was like a complete navigation problem where you had to basically take sensor values, have like a line following implementation, and do like a navigation task. So that's something sort of challenging, but maybe doable in a week's time. Uh,
We can use Raspberry Pi for all this, right?
oh, if you have hardware, yes, definitely. In fact, yeah, if you have hardware, I would recommend using Raspberry Pis. Uh, yeah, you can. Do you have like a Raspberry Pi camera with you?
Yes, I do, but it's like a 5 megapixel camera. I'm not sure if it's good enough.
It should be good enough because I've seen a bunch of implementations with very lightweight sensors. Um, so I mean, people have done this using a simple ultrasonic sensor. Uh, yeah. So yeah, I'll tell you what. So here's what you can do. You can try and implement like a behavior tree that does simple obstacle avoidance, or even you can think of doing like a navigation task using a behavior tree. See if that is possible. You just have to think of a bunch of rules. And I think coding wise, that will be simpler than implementing A star because A star can get a little messy. So maybe you can think of doing that. Uh, so you can also see how like basic AI also ends up working out. Um,
Most of the sensors that I have, I think they're compatible with Arduino. Can I like pair them up, Raspberry and Arduino?
yes, you can. So do you have an Arduino Mega? Or do you have an Arduino board?
I have an Uno.
Okay, you have an Uno. That should be able to. That should work out. The thing is, when you connect a Raspberry Pi with your Arduino, right? The power sources are operating are completely different. So I've actually done this. So you would need like a, yeah. The only thing is you would need an extra piece of hardware. Yeah. So if you're using so I've actually done this in my robot for my master's work. So you can read data coming in from Arduino using the Arduino board, but you can have the Raspberry Pi make those decisions, like whether to turn left, to turn right. You can have those decisions made by the Raspberry Pi since it's an actual computer, and then you can transfer those images information, the decisions back to Arduino, and let the Arduino actually turn the motors. So that's what I did. But the only thing for that is you would need this particular piece of hardware. It's a converter. Um,
Oh yeah, that sounds.
but I'm not sure if
Is there any way I can make it work with like simply Raspberry or Arduino if I don't have the controller? I don't think Arduino can because it doesn't have much computing power, but maybe Raspberry can.
yes, I think doing it on a Raspberry Pi is easier if you can get if you can read the sensor values on a Raspberry Pi, then you're done. Then it's basically an issue of coding it up. So actually, it's possible to do it in Arduino too. Don't underestimate Arduino because I've actually seen neural network implementations on Arduino. So surprisingly, So you can do
Neural
something with,
networks and Arduino. Oh,
yeah, yeah. It's kind of surprising, but yeah, it's doable. Somebody has done it. So if you can implement a neural network, I think you can implement a few behavior tree rules.
yeah. Basic
So
things can be done.
so if you're doing a behavior tree problem, right, I recommend you checking out this particular link. This is my friend's master's thesis. He's optimized a behavior tree, but maybe you can think of like a simplified version of this. uh, and he's also done it in VRAP. So what this guy did was he made a robot. He made a very small robot. He implemented it in VRAP. He brought it over in VRAP, and then he wrote out an obstacle avoidance code. So you can think of like a simplified version of this. Uh, you can think
Did
of,
he make a robot all by himself as well?
yeah, it took him like 2 years. Yeah.
Oh,
Yeah, but you don't have to do all that. You can basically just have the rules implementation. Just like if you see like a maze, right, put a maze in VRAP, and then construct like 4 or 5 rules to your liking.
yeah.
So you can
Sounds
probably do that in
yeah.
a week's time, I would say. At least
Sounds
like
good.
a
Then
rough
I can add
implementation.
these projects in my CV, right? Like they're good enough to add in your CV.
I'd say, yeah, you should probably highlight the artificial intelligence part. uh, So yeah, if you want to put something in your CV as a final year student, you probably can, because this guy did it for his master's thesis. But I would also, recommend you get in touch with OpenAI and projects involving that. It'll take you some time, but I think it will be worth it. Uh,
Guess it's more interesting anyway. OpenAI.
yeah, yeah. So this is a sort of thing that, like I said, right, evolutionary robotics is that sort of field which employs these sorts of algorithms, both on a hardware level and on a uh, software level. So I think in the long run, this is something that you should end up doing. Uh, yeah, this will take you maybe a couple of months just to get familiar with what RL is all about and everything, but I think it's worth the time and effort. Uh, yeah,
Yes, it sounds good. I'm
yeah,
already learning deep learning, so I think next I'll move on to RL.
yeah. So deep learning is also used in RL. So yeah, you should have a good head start.
Yeah, it uses fine tuning, right? Like the same in convolution neural networks.
So the architecture is completely different. The CNN's architecture is completely different from a neural network architecture used in reinforcement learning. So
Right.
so they are neural networks at the end of the day, but their architecture is completely different. And because their architecture is completely different, the things that they do is totally different. So yeah,
Yep, that makes sense. Yeah.
yeah. So
Like it's totally separate, right? Reinforcement learning is different from machine learning.
not really. So reinforcement learning is a branch of machine learning, but it's not very much talked about. So usually when you talk of machine learning, you talk of supervised learning, unsupervised learning. So this is a third branch of machine learning, which is mainly,
Yeah, right, right. Yep.
so yeah. So this mainly has applications in robotics specifically. So you don't see them. So whenever you do Kaggle challenges, you won't see any reinforcement learning implementation, but it is a branch of machine learning. So see, right, is it?
Yeah, right. So like the major difference between the two would be we can't get better than the data itself in machine learning, right? But we can in reinforcement.
Yeah.
Like
So
we
the
can,
difference between
yes,
supervised learning and say reinforcement learning is, with supervised learning you have the answer with you. So you're basically given training data. Right. Suppose you want to predict whether something is a cat or a dog, right? You are given historical data with a bunch of images, right? And the algorithm tries to learn and generalize for future images, right? So you're given correct answers, and then it is asked to predict for
yep,
unseen images, right?
yes,
But for
yep,
reinforcement learning, there is no correct answer. So
Yeah.
the algorithm has to figure out how to convert this input space on what the robot sees to a set of actions. All right. So there
Yep.
is no correct answer. So that's why if you watch that Moraya video, right, you could see in the first
Yeah.
few generations, it did absolutely
Yeah. It's
nothing.
like really bad. Yeah.
Yeah, it did. Yeah, in fact, the behavior tree could have done much better. So, but then
Yeah.
it sort of learns as iterations go on. Uh, so neuroevolution is sort of different from reinforcement learning in the sense that neuroevolution is based on evolution, like survival of the fittest.
Yep.
Whereas reinforcement learning is sort of like psychology based, but at the end of the day, they do similar stuff. So in its first iteration, it does horrible. It doesn't know what to do. It doesn't know that moving right, pressing right makes the thing move in that direction. But then in the next generation, it sort of corrects itself and it tries to explore, and then it proceeds in that way. So there is no correct answer. It has to figure out the answer in the first place. So that's the key difference. So does that make
Like,
sense?
is it possible to train? Yeah, yeah, it is. It does. Is it possible to train something like that on like a normal computer with like gigabytes of like
Yeah.
um,
So
graphic cards,
not really.
or
So
do we
I
need
would
like heavy server?
no. You don't need a server. Have you
Collab,
heard
yeah.
of? Yeah, you've heard of Colab,
Yep,
right?
yep. Google Collab, yeah.
Yeah. So use that. Uh, in fact, so have you heard of Kaggle? Uh,
Yeah, yeah, I've heard. Yeah.
so there was actually this challenge on Kaggle that I think would have used reinforcement learning. It ended just last month. I wanted to do it actually, but I didn't get the time. Uh, so
Yeah, they give you like prize and stuff, right, for completing the challenges.
yeah, they give you a prize, but usually it's just supervised learning problems. Uh, but last month, there was a particular challenge on like intelligence. So I think you could have used machine learning for that. Where was that? Where was that?
Also,
Abstraction
I
and
was
reasoning.
wondering, like, to solve these AI problems, do we need like dynamic programming, like sort of knowledge, or like knowledge?
Very good point. Very good point. So reinforcement learning is like the evolution of dynamic programming.
Uh,
So in lesson 4, I talked about the NASA Apollo landing, right?
yeah.
I sent a link to you guys, right? That
Yep, yep,
used
yep.
something called optimal control. So optimal control is like the opposite side of a coin to dynamic programming, and reinforcement learning was like an evolution of that. That's why I said this is
Okay.
like an evolution of control.
That makes sense.
So yeah, I'll send you. So this is the thing that you should be looking at. So this is the challenge name: abstraction and reasoning. So this is a unique challenge in Kaggle, and I think it did require some RL to be worked at to be used. So have a look at that. So you can get started with that. Okay.
Yep. So I need to do dynamic programming as well, right? For like getting good at AI and stuff.
Uh, so this is how I think your trajectory should go. So do you know what genetic algorithms are?
I just know the basics,
Yeah.
uh,
So
like in
uh, yeah. So go through the theory of optimization. Go through what genetic algorithms are. It's a particular type of optimization algorithm. Once you go through that, you can think of looking into optimal control. Then you can think of modern reinforcement learning with deep learning. Uh, yeah.
right. Okay.
Yeah. Oh,
Sure,
okay.
sure.
Okay. Yeah. There's another question. Uh, what would be helpful for me if I want to do MS and CS and end up in astrophysics? Oh, okay. that uh, that is uh, an unconventional route, to be honest. But uh, I'm not sure. So, as far as the subject of robotics is concerned, there are actually some things that you can pick up from here. So, if you look at lesson 4, I've talked about optimal control. All right. Uh, this is something that you should look at if you want to do something like I don't know, something related to space, and this is also related to robotics. So yeah, this is one term that I am familiar with. I don't know too much about astrophysics, but this is something that is related to some extent. So uh, if you have the PPT to lesson 4, uh, so you can have a look at this particular slide in lesson 4. I've linked this. So this is a starting point. So I would say I'm not an expert in astrophysics, but if you want to tackle it from a robotics perspective, then this is your starting point. Yeah.
I may be able to take this question in the sense I won't be specifically answering. We had an astrophysics professor in April come and do an AMA, and he had said now astrophysics they're using a lot of machine learning, right? So I don't know if Avni was asking. Yeah, so I think she's asking based off of that. So I
Oh,
think
okay.
yeah, I think if you do anything related to ML and AI in and especially something to do with I don't know statistics and even maybe computer vision, I think you can
Yeah,
end up in astrophysics. Yeah.
exactly. So do you know that image of the black hole that was taken, I think, last year? That it was quite famous. It made news everywhere. Uh, so uh, yeah, so that was done using computer vision techniques. So yeah, that's actually a very good point that you brought up, Pratiksha. So so
Mm-hmm.
you should so that's a good starting point for you, specifically from an ML perspective. Yeah.
So yeah, I guess that brings us to the end of a wonderful series that Sharat has done, basically covering starting from the basics of what theory do you need to understand to be able to get into robotics, to the point of building something yourselves and running it and understanding the inner workings, like especially today the AI aspect of robotics. So this is a great set of sessions, Sharat, and thank you so much for doing this. um,
Yeah, it was actually very nice also for me. So I had to
yeah,
relearn a lot of stuff, and it was fun on my part as well.
great
And
for attending and patiently trying to build new skills. It's not always easy to build new skills. It requires a bit of hard work, and that's where experts like Sharat come in who try to make it so easy for you. They try to use all sorts of media and links and videos and stuff that you traditionally don't experience in a classroom, right? So there's a very casual and fun learning environment. And thank you, Sharat, so much for making it so interesting.